Hello, I'm Dr. Elizabeth Cook, and I'm here to continue the conversation around all things grid modernization. One of, and it's a very large topic, of passions of mine is the Integrated Distribution Planning term, IDSP. And something I said in the last lecture, if you have not watched it, is the language we use, the words we choose, are very powerful. So the benefit I have right now in my career is working with an organization called AEIC, Association Edison Illuminating Companies. It was actually established in 1885 by a group of gentlemen that purchased Thomas Edison's equipment that he had a patent over. At the time, it was dynamo and some wires, and they were developing and building out grids in their areas that they lived. And it came to be a lot of questions, and really design and invention was occurring. So they would get together, and the first time was in 1885. At first, I think it was 6 to 8 groups, and then it ultimately came over 100 utilities were represented in the conversations, Thomas Edison included. The idea behind these workshops, or at the time committee meetings, was to discuss the technical and operational challenges that were occurring with the new innovation and creation of the electric power grid. 140 years later, fast forward, this organization is still intact. There's 185 utilities that are active across 14 committees that are taking on very large topics, especially during this transformational time. The fourth industrial revolution is what we're calling it. And so one topic that has been discussed and really being empowered comes from what do we do with this distribution grid that is becoming very dynamic, all of those changes in technologies and those disruptions thereof. So the ability for the utility and all of the external stakeholders to come to the table and make decisions on the assets that exist based on where they are today and plan for where they need to be and what they need to do in the future to come. This educational series that I want to show up here and discuss with you is really centered around the idea and the phenomena of operational excellence, the importance of the leadership at this time, and ensuring public engagement, but discussing the technical and operational fundamentals of the electric utility industry to then inspire and guide stakeholders through this transformation. So today is an output or a cohort or collaboration of a discussion that I got to have the opportunity to be a part of and lead with AEIC. Not only was the work stood up and created from a significant amount of contributors over the last 20 years to get in a room and talk about the beginnings of IDSP, but really from the perspective of the who and the how. So at this opportunity, we had 18 utilities that were representing all parts of the states across our country as of today to get into the nitty-gritty and understanding what the systems are and how the data can be extracted and what technology is required to be able to do so, and then discuss the capabilities that are being unlocked. Also, a big part of the conversation was the who. Which groups within each of the utilities were engaged, which groups were going to be impacted, and then ultimately which groups need to be supported during this transformational change. So the IDSP is a map, is a guideline. I think all beings work well with seeing where we're headed. So the goal of the workshops and the conversations is not only to create best practices guidelines, but really to identify the correct language and to understand the who and the how. Because I think the what, and it's occurring at various rapid, expansive ways in some parts of our territories, and then it's also kind of slower in others. But the general founding principles are the same. So with the IDSP, there's multiple segments. The first is really the planning objectives and overall criteria that need to take into consideration. And then you kind of step into a roadmap. And today we're going to focus on the changes of interconnection of customer requests and also load forecasting, how that is changing. When we think about interconnections, there is a group within utilities as of today, before DER was really a buzzword, a group of engineers and various individual contributors would take the information from a customer of how they wanted to interconnect to the grid. Predominantly, it was a load request. But what has been changing is now our customers want to connect generation, aka solar, energy storage, vehicle to grid, not so much right now, but it is coming, as well as those demand response or energy efficiency devices that create the behavioral opportunity of a customer, DER. Those interconnections are becoming onesies, twosies from a decade ago to now hundreds, if not thousands, per month that need to be taken in by the utility, reviewed, and then ensured that the interconnection will not cause harm to the overall performance of the grid. Another area that's rapidly growing and changing is load forecasting. Fun fact, one of the committees that first spurned off in 1885 was all around what is your current load? And so big discussions were on how do you quantify and then predict and then build to said load forecasts. So the ability to take in a large amount of data, at the time it was large, in 1885, and create the charts that then could be used to the overall planning of the grid. I mean, in itself, very powerful. And something that I mentioned in the previous lecture is the load of the grid, which is really the customer's demand or customer request. So when I say load, it's the usage of the grid, the quantity thereof, has been very predictable in the idea that we all go to bed, wake up, go to work, come home, make dinner, go to bed. Average. Also, the amount of load that was being requested year over year really stalled out when we came to the realization that we cannot continue to use this much energy as the grid will not be built quick enough to meet the demand. So there's been, over the last 40, 50 years, a lull in the growth of load. But as I mentioned in my previous lecture, this is changing rapidly. And the methods and the tools and the data that is needed to have more accurate loads is becoming a very hot topic. So I'm going to dive in a little bit on the interconnections and really the who and the how and really what is happening and things to think about. Also, I'm going to dive a little bit into load forecasting for this particular module. Lastly, I'm going to tie it in to the overall integrated distribution system planning as I shared earlier, and then talk through some challenges and gaps, and then predominantly a call to action for those listeners who are either here learning everything they want to learn because they want to be a part of the solution, or those that are currently in it and in it deep and would like to have a network or an area where you can come as an AEIC member to really continue to be a part of the discussion, as this is an ever-evolving topic, and with everything in operational excellence is all about continuous improvement. The purpose is really just to provide insights and plant some seeds around best practices. The key discussions is really what are the outcomes, what does the data exchange looks like, and really the decision-making processes. Understand the current state, and then help identify and really highlight where the gaps are and how we as an industry, and when I say we as an industry, that is not only the utility operators and folks within, but it's those sitting within the power of helping to drive decisions, such as the customer and our regulatory bodies that help make decisions on how the utilities themselves can move forward. So, interconnection. One would think it could be a simple coordination. However, the coordination is very complex between not only the utility, the DER owner, and of course the regulatory bodies. This aids in the complexity to the interconnection process. And when I say regulatory bodies, there are two regulatory bodies I think of. We here in the States have a state regulatory body, which is a set of commissioners that make rulings based on utilities filings or rate cases of how and what they're going to do in the next set of years and how much it's going to cost and how it's going to be paid for. And so the state oversees the distribution grid. There's even a larger regulatory body, it's the federal, which oversees the transmission grid. So depending on the utility's assets that they own, they are either working with the federal if they own transmission and generation, and they're working with the state. And if they're operating within multiple states, they're working with multiple regulatory bodies. So some of the utilities have distribution assets across multiple states. For instance, one utility has 9 sub-utilities under the parent company in 5 operating states. So you can see, as an entity, those conversations, everyone's on a different timeline, based on which state you're sitting in. The other aspect of the complexity is the DER, so the developer or the owner of the customer device. So there are a significant amount of developers and there's a significant amount of technology that builds or creates the ability for, say, as an example, a solar connection. The solar interconnection, what the utility sees is really an inverter. And so an inverter is a new asset that has new capabilities and therefore is connected to the grid. So from a utility's perspective, they have to understand what the inverter technology is and how that inverter will respond to grid scenarios. So that interconnection of technology and information share is pivotal to be able to ensure the proliferation of any said inverter or design model won't have a detrimental impact to the overall performance of the distribution grid, as well as if that inverter wants to connect on the transmission grid. Another big part of interconnections is there is a precedent and also now a capability, which is something that did not exist 10, 15 years ago. But it's for the utility to have a holistic map of all of their distribution assets connected to each other, and also have the technology and the data to run a power flow solution. This in itself is challenging and difficult, and is something that utilities are actively pursuing and building as we speak today. After this data is constructed and the power flow and the solutions are available, when we introduce new technologies, new capabilities, adds new processes, changes existing processes, as well as the people that are required to do said processes. So just consider anytime a new capability is unlocked, it requires a reskilling and or a change in how business was done previously. So when I say hosting capacity maps from a utility, this would be a significant benefit to have at the fingertips, but to be able to create it takes time and effort and resources. But let's just say the hosting capacity is available. The data within it is to share with multiple audiences what is the capacity or capability of the distribution grid. These maps can be very powerful. However, they can be a detriment if they are in the wrong hands or in the hands of someone that doesn't understand the full picture. They are a great resource to be able to start a very synergistic, collaborative conversation. The hosting capacity in its name itself is limited. One key aspect of an interconnection request is, does the current grid or does the current location of the interconnection, wire size, and transformers that are associated to that particular point on the grid have enough capacity to handle the injection of the size of the generation that wants to be connected. But not only is capacity a data point that the engineers have to understand, their voltage health, the coordination of the existing protection devices, as well as all of the other devices that are already installed to help regulate and can manage the actual flow of the existing wire's performance. And so there's actually a very heavy subset of data that's required and information that comes from those studies. But the hosting capacity map in itself could be very limiting in what it's able to share, because this information changes when interconnections are connected. So you have to have not only the ability to create the first one, but then the ability to create a process to ensure all of the data that's being provided to the systems to run the analytics stays up to date and continuous. For this module is just to be aware of what they are and to really do the due diligence to build up the rapport of questions and curiosity around what these maps are and how they can provide value, not only to the particular person asking for the connection, but to the regulatory bodies as well as the utilities. The other area is an interconnection queue. This sounds very simple and something that you could execute quickly. The idea of a queue is a utility has, say, 500,000 customers, 500,000. customers that they are required by the regulatory bodies to ensure safe, reliable, and affordable power based on a construct that we've created over the last 100+ years. The queue of itself is the number of customers that come to the utility and ask for a unique interconnection. So at first, this could be something as simple as 10 or 20 customers, individual, on various sporadic points of the grid, asking for an interconnection and gaining their approval from the utility. But as these technologies become more available, aka they're scalable and affordable to the masses, those requests become more frequent and become larger. So the ability to create a technology or a tool that imports the information, log on to a website, add in all of your information, it gets imported into the system, and then someone behind the scenes is actively testing and reviewing and ensuring that all the information is up to date, and then processes could be made. There's a cost of processing these interconnections. And depending on where you sit or at what maturity state you're at, there is a time period that it will need to be endured to ensure you get those systems up to place. So I just share that when we say interconnections in itself has robust and deep changing methods to the overall current processes that exist. So that should in itself trigger significant change in the who and the how things are being done. So, enablers. I'm not here to share all of the big hefty problems, but to know that there are enablers and there's technologies and solutions that have created effective interconnection processes. The ability and the time of creating robust conversation amongst all of the unique perspectives of how the grid performs and the experts within the utility come to the table and have a discussion of this is what information we need, this is why we need it, this is what will happen if we don't get the adequate information, and here is ultimately a matrix, an operating profile. It's not just what is your voltage, what is your current. There's a lot of standardized collection of operating characteristics, which means it's being blessed by an entity that can stamp it approval. You have to be very careful of the language you use because sometimes the wrong word can trigger a certain audience or stakeholder to mean something different. But let's just say the operating profile matrix that could be developed is a very repeatable set of information that is available at this time for utilities to tap into the network and build for themselves. Also, the unique perspective of the challenges the electric utility faces is every grid is like its own fingerprint. The way it was created, the way it was developed, and then the way that it was maintained over the last 100 years is dynamically different across all asset owners. So that's one thing to consider. There's no peanut butter spread to these solutions. The other enabler is something I spoke of, is the host and capacity analyses. So this is a GIS, Geographical Interface Information System, tool to visualize the capacity of each feeder, considering multiple types. So it's a package, a software, a tool that has been developed over the last couple of decades by industry experts to be able to model the systems and run a very large amount of simulations to determine a yes or no decision. I mentioned this a little bit in the last one, but in itself is a very complex tool that has been built by very large sets of minds coming together to create something for the utilities to unlock the powers of these DER. Another enabler is the interconnection evaluation process. So clear evaluation process that can be packaged and shared to many stakeholders, as well as then taking the next step to automate some of the key or simple yes-no decision-making powers to then allow some of the easier or smaller projects to move through quickly. So just creating that process to evaluate, first it has to happen manually so that those that are in charge of the process understand each step. And then as that manual process becomes redundant and repeatable, you build on the ability to automate. Another tool and enabler is an interconnection project tracker. So something that I think is commonly known in the industry is the ability for, say, a customer relations manager tool. So just a system that can accumulate all of the information in the varying queue statuses, enhance the transparency and accountability of not only the developer, but the utility to deliver answers quickly. And then it provides an opportunity for effective management. This again seems very simple, but it's a change in processes, one that did not exist and then is now very rapidly occurring. You have to resource, aka hire or reskill someone to be able to do it. You have to build the tool itself, and then you have to communicate out to all of your customers that the functionality and capability exists. This takes time and effort. And then lastly, something that I think we don't talk about enough is kind of closing the loop, creating post-interconnection evaluation metrics. And so after interconnection is within the grid, being able to track and evaluate how long did it take, how much cost was it, what was the performance of the system. And it's not to be done in a way of detriment, it's to be done in a way to improve all conversations and processes moving forward. As humans, when we're asked to reflect or review work that has been done, there's almost this hindrance of why does it need to be done? When we're thinking about all these massive changes that we're asking an entity that has been doing something one way over a very long period of time, those questions tend to not always get the attention needed because project is executed. So it's just something to consider of the importance of creating these evaluation metrics so that you can improve and not continue to do some of the simple things that are very laborious and inefficient, and really from a worker's perspective may not be empowering and fruitful. Your path forward for an interconnection, this was just a kind of a summary of a lot of the work that's happening in the industry, and then also things to take away from this conversation to really create and ensure the conversation moves forward. I share these from the perspective that the maturity of some of the enablers I spoke of are present and available, as well as some of the things that we need to evolve and develop as those that are more mature and handling these mass interconnection requests have identified as additional needs to the basic tools that we just shared, is dynamic hosting capacity. So it's allowing certain loads and DER resources to adjust the power imports exports of which they ask or specifically need to. What does that mean? As of right now, we hold each other to the idea of, okay, you, developer, are asking for 1 megawatt. You cannot go below or above 1 megawatt. The number is static. What if we change and develop the tools and the capabilities and the language to create a contract that allows that developer to maybe only inject a 0.5 megawatt at a certain period of time, but then could inject 1.5 at another time? So really giving it a dynamic interconnection request or a variability. The opportunity here is to create faster and cheaper interconnections. And this is something that also could be said and could be done at the transmission level. But we're predominantly speaking here distribution, but doesn't mean the conversation is limited. So there's opportunities to then expedite said interconnection as well as reduce the socialized upgrade costs it would be to then perform. So just to kind of bring us back, when a developer asks a utility at this point in time for a 1 megawatt connection, that 1 megawatt connection could trigger a large system upgrade that utilities and those that are connecting would have to absorb. So the idea is if the system, based on all of the dynamic load shifting per the capability of the hosting capacity analyses, it actually shows when and how much said device could inject without triggering an upgrade cost. That is why you could have faster and cheaper interconnections. However, the challenge is revising existing interconnection methods that are already fluid and moving forward is a challenge. Having the permission to do so, and then having the resources, the time and money to then communicate and push to new revision. So there is a financial impact to this from a risk perspective, as well as any change of large systems in place requires that. So Another area is not just in allowing the injection to change based on time, it's modifying the rules on payment, compensation, and or the tariffs that exist today. Another path forward for interconnections in the idea is batched interconnection, or some may call clusters. So really giving the opportunity for a bucket of interconnections to come into the queue at the same time together with a unified cost, instead of this sequential or serial interconnection queue process. The advantages of this is it expedites screening process and it gives the utility a greater visibility on the overall system performance. The challenges will really be in holding all of the individual developers that are within that cluster to actually connect. And so that's kind of why we go back and forth as an industry and various entities move forward with one or not the other. But trying to figure out that discussion, understanding those that are at the table are being open and synergistic and aware that these technologies in itself could help with the enablement and the transformation of large load growth as well as dynamic energy sources. So that's interconnection in a nutshell. Now again, I could create a whole lecture on multiple hours, all into getting into the weeds. But those are kind of the big fundamental building blocks that the industry itself are working on. So load forecasting, many challenges here. And as I said originally, this is something that has been at the forefront of those that perform or are in charge of the overall operation of the grid for the last 140 years. And we have been a space really for 110 years where it's very predictable. And the technology has not truly changed or has driven the desire or need to change. So the first challenge is this evolving customer class. And it's including the electric vehicles, the building electrification, these large data centers, and really something called the digital currency mining. Those are just some examples of our load forecasts being dynamically step change, not even exponential, overnight in regards to how the grid has to be prepared for said requests. And so when you're thinking about forecasting, there are systems and processes in place that have been used for decades for a 3, 5, 7, 10-year forecast. And those forecasts are actually tied to financials. And those financials then allow a utility to execute, maintain, operate a grid. So it's a very catch-22 that the load forecasts have to be accurate so that you can predict the revenue to ensure that the existing grid stays standing. That leads into the accurate demand predictions. When you're thinking about the complexity of the adoption, you are then bringing in a very large amount of heavy mathematical equations. And I guess I'll leave it at that. So this in itself could be a dissertation of hundreds of bright minds to really come to a point of agreement of the most accurate methodology, but there is not one size fits all. My point of bringing this up is the idea that this will require new systems, new processes, and really the reskilling of the folk that exist today on doing what they knew to get to where they need to be. The other area is organizational integration. This is a big one. Integrating forecast modeling across an entire organization is very challenging. When the load forecasting team sat in one group and no one really paid a whole lot of attention because they trusted that the predictability of us customers has been a certain way for decades, really you didn't ask too many questions. However, now with all of the changes that are occurring in the utility and all of the groups that are being stood up that are being asked to understand how many EVs are coming, how do we know when solars are connected, how do we look to the economic state of our existing territory and deem if there's a large company that wants to build a data center. All of these are very diverse and different points of conversation and data. So the last is a specialized team. A team that has this diverse skill set is unique and new. You need to have your statistical analyses. You need to have the ability to manage multiple data sets and the construction thereof. And then you have to be agile in leveraging new software solutions. So that in itself is a large amount of work, but being aware of it is the first step to solving any problem. So, enablers for load forecasting. I won't go deep in the weeds for this one, but the idea is that there's a significant amount of work, and it's around the systems, the data, and the tools. Robust and diverse load profiles are needed and required. We, the utility, need to utilize the AMI data, which is data that we've never had before, but will become more and more powerful. You have the ability now to create load flow analyses, as well as layering that with your probabilistic analyses. You also have the implementation of DERMS. So with all of this change, now we have the capability, which means we have the technology. Now we just need the who and the how to implement software that can visibly see thousands, if not millions, if not billions, ultimately, of dynamic change, and then manage it accordingly. We have robust systems and data systems that are available for data collection, as well as determining the overall demand metrics based on bottoms-up analyses. New word, but load forecasting has been top-down, looking at your substation feeder heads, taking the numbers, scaling some value. Bottoms-up is taking all the data from your AMI, pulling it into a system, running a bunch of analytics to come out with various curves. So you're utilizing still the top-down, but also the bottoms-up, and then integrating those to get your best solution forward. So tying those two topics into the overall IDSP is really kind of the beginning of the large set of systems and analytics that is needed. I look forward to continue to develop out these conversation pieces as we get into the other business units that all of this change will really trigger, and what we should be thinking about in regards to the who and the how to get the job done. So with that, I'll see you in the next episode.